Okay, so up to the last class, anyone having any confusion, any doubt? So in the last class, we have completed the previous module, and that was about powder metallurgy. And now I think as we have got sufficient numbers, so we can go ahead. We can start the next module. Okay, and this is the today we are going to start the next and the last module, module 6, which is basically about different surface finishing operations. Okay, so prior to starting this particular topic, this particular module, okay, let me still ask you whether do you have any confusion, any doubt that you want to clarify from any previous module? Let me know, someone. If no, we'll move ahead. It seems like no. Okay, so now in this particular module, we are going to talk about surface finishing
Sir,
operation.
Tamo is waiting, sir.
Yes, what happened? What happened,
Sir,
Manas?
Tamo is saying he is unable to join.
Why? Almost most of you have already joined. So what is happening to Tamu? We cannot see him entering, also trying to enter, because otherwise one notification will come here, no? My share screen is
Okay, okay.
already been shared.
Continue, sir, continue. Actually, he is giving a message on WhatsApp. That's why.
Okay, okay. Let him just reply him back. That means try once again, because you can see others are most of you have already joined. Okay, and I think he is here in college university hostel itself. So internet problem should not be there. Internet is fast. Let him try once. Okay, because the notification also has not come. That means he is trying to enter like that. Okay, so now you do that. Okay, Mas.
Yes, yes, sir.
Okay, so now in this particular module, basically we are going to talk about various surface finishing operation. Now, from this word surface finishing, prior to discussing about the whatever is this particular topic, okay. So let's have your views. What do you understand? So do you understand? Suppose surface finishing, that means something like we are going to hammer it or break it or something. That means we are going to finish it. Sometimes you sometimes like scold your friend, na? Okay, I'll see you, I'll finish you, or like that. Okay, so I have seen some like rock team and all. He always like he has the headphone. He plays this game. What is this called? What is the name of that game? Rock team. PUBG. Okay, and he keeps on like tung 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 tung. He keeps on like using that whatever is type of different guns, and yeah, I'll finish you like that. Okay,
ফিনিচিম ছাৰ ফিনিচিম নহয় ছাৰ এতিয়া ইয়াততো হেৰি চাই ল'ম তোক বাহিৰত
uh,
সেইটোহে ছাৰ
okay. So it's a similar kind of thing. Okay. So now that do you think that this surface finishing also says something like this? That means you have got a particular surface and you'll just break it, hammer it down and break it down or like that, or you'll finish it. Is it that do you think it's something like that? Surface finishing. Because this saying surface finishing operation. Are you going to like finish like by doing destroying it and breaking it and like that? What do you think? Is it something like that? That kind of operation we are going to discuss, or something else? What is in your mind? Let's have a little chat.
কমপ্লিশ্যন ছাৰ কমপ্লিশ্যন
Completion in terms of team. What do you think? What kind of completion?
এনি ৱৰ্ক পিচ কমপ্লিশ্যন লাইক something like that ছাৰ
Okay. So others. Thank you, team. Others. Anyone else? Manos, what do you think? Balam, what do you think? What is your view? Sampiler, Dixita. Seems like if people are not active, you have just joined the class and you have. Okay, anyone else would like to give you his or her opinion? Okay, so this yes, so this surface finishing doesn't mean like breaking or something that kind of finish or like that. Okay, so definitely just like Raktim said, so like somewhat it is related to completion and all. Okay, and actually this surface finishing operation, actually there are certain operation which is required to be carried out sometimes, and sometimes it is very necessary from the perspective of like functional requirement itself. Okay, so now what happens, uh, what we intend that whatever is the manufacturing process, okay, be it machining, be it casting or whatever. Okay, so the surface will have certain undulations and all, and it may not, that particular surface, okay, it may not meet the functional requirement which will be required for during its service period. Okay, service period of that particular part. So now in those cases there are various like operation which we carry out on that particular surface. Okay, different engineering operations. So those are actually they're like certain surface treatment process and all. Okay, and they actually are the kind of surface finishing operation. And under that, with surface finishing, mostly we basically discuss about all those like making the, you can say, the surface bar free, free from like roughness. Free from roughness means you cannot have the totally free of roughness or like that. Okay, but the roughness value we are going to minimize. That means a smooth surface you are going to trying to achieve or like that. Okay, so those are the various type of surface finishing operation that we'll discuss. So now we'll come to the formal introduction. Now what happens, so we know that all the whatever is the parts, okay, everything is being manufactured by, has to be manufactured by some or the other type of manufacturing methods, right? And depending on the type of manufacturing method that has been that you have used to produce a certain part. Okay, so it is definitely going to that particular process itself, as well as the process parameters, how you have conducted it, what are the process parameter you have selected, and what is the capability of that particular manufacturing process. Okay, so it is going to influence the surface properties of that particular part. Okay, and we know that these surface properties actually, okay, it is going to significantly affect the way that particular component is going to function in its service. Okay, that means the surface which you achieve in a through a particular type of process. Okay, so it has got a tremendous effect on the service life of this particular part. And we know that our requirement is, that means during that particular service of this particular intended service of that particular part. So definitely one thing is certain different things are there. One thing is like the, it should be, service should be efficient in terms of like for like it may be the energy efficiency, maybe uh, resistance to wear and tear or something like that. Similarly, that's another like requirement. Maybe sometimes your intention is, so if you are talking about some decorative items and all, then that it should be kind of shiny, and that kind of pleasant look or that kind of thing also takes like it affects our mind. Okay, so now apart from this influencing this kind of different properties. Okay, so the different manufacturing methods and different processes that you utilize, it also gives rise to a variety of smoothness or roughness. Okay, they can be related. Okay, they can be interrelated, smoothness or roughness. So this different process that you select for producing a particular part. Okay, it is definitely once going to influence the surface property. Apart from that, you are going to get a certain level of roughness or smoothness on the work surface, along with some contamination, which definitely is not within the final required tolerance level. So if that is happening, okay, so suppose if for a particular part, for a particular product during its service, suppose you knew that, suppose two mating parts, it is there, and they will be having suppose some relative motion in between them. And for that particular service to have as if its proper efficiency or proper functional requirement, suppose you need that particular surfaces which are there, which will be having relative motion and all. Okay, they should be suppose have a they should be properly they should be smooth and all, and maybe the roughness level, suppose 2 micron, 4 micron, that kind of roughness, suppose surface roughness that you want. Okay, for that particular surface. But the way or the process that you have selected, the manufacturing process that you have selected for producing that particular part, suppose you have already manufactured that particular part for an intended service, but the surface which you have obtained, okay, definitely depending on the capability of that particular process, and the equipments that you have used, you are going to get a certain level of roughness on that particular surface. And if that particular surface roughness it exceeds or it doesn't meet that required level of tolerance, okay, so in that particular case, that particular part will not be suitable for that particular intended purpose. So in those cases also, you have to get the required level of that particular surface roughness. So now I believe all of you have got different surfaces around you. Maybe the surface of your table on which maybe you might be having your books and all. Maybe the surface of a whatever surface you consider. Maybe the surface of the that mobile screen. Okay. Now you try to like have a look on it as well as try to have a feel on it by rubbing your hand against it. So which one do you think is smoother from your perspective? Or which one is having less roughness? Ultimately, less roughness means it is smoother. Yes. What do you think? The table surface, tabletop surface, or the mobile screen surface? Okay, considering it to be somewhat intact, not a cracked one. You can have the feel, right? Maybe visually also you can say, okay, and similarly by touching by your fingers or hand, okay, you can have a particular feeling, and you know that both the surfaces it has got a different level of smoothness. Okay, different level of smoothness means it has got different level of surface finish or surface roughness. So now if suppose if that is this, suppose, sorry, so suppose this is a surface. Okay, now in that particular case, suppose if it looks like, suppose this is the table surface that you're on which you're there. Okay, so only by visual inspection, okay, normal by naked eye or maybe just by touching by your hand, okay, you may feel like it's a smooth surface. Okay, but under microscope, under high magnification, if you see all the surfaces, whatever we call it, like it's a very smooth or whatever be it, okay, or smooth or rough. So depending on that, if you look at this particular surface under microscope, then you may see some this kind of feature, okay, undulation, up and down kind of feature on it. And actually they actually give rise to that particular level of smoothness or roughness. So smoothness and roughness, they are interrelated. Higher is the roughness, higher, then lower will be the smoothness. Really, lower is the roughness value, higher is the smoothness, right? So smooth and rough, they are actually two interconnected term. Okay, less roughness means higher smoothness, and that is what is generally is our intention. Okay, so now if you look at this particular in a surface, so this surface will have certain undulation, okay, certain up and downs and all, okay, and that actually gives rise to whatever is this particular roughness or smoothness value. And depending on what is the level of this particular wave, this kind of suppose surface, okay, suppose this is the main line. Depending on suppose what is the risk and value under microscope, so you'll be getting different values of the surface roughness for both the two surfaces. Suppose this is for one surface, okay, suppose this is for under surface, okay, then definitely depending on that, so you are going to get different values of surface roughness there. Okay, and now in that particular case, if you think of any engineering application or maybe the normal day-to-day life, okay, so what is our requirement? In general, a smooth surface is a kind of requirement from various point of view. So what are the various point of view? See, a smooth surface, it is aesthetically pleasing. Okay, aesthetically pleasing means suppose if you think of to if you are going to buy suppose some decorative products and all, okay, so in that particular case, definitely the product which surface is kind of shining, which is shiny, or that means very smooth surface, okay, that particular product will people will prefer, okay, which is having a very good shine, just very like feeling, it feels good to touch and all. Okay, so aesthetic appeal is there with respect to the surface. Any surface if you think of, okay, any product, so the product which is having a good surface finish, that is higher level of smoothness, generally people prefer it. Similarly, from ergonomic point of view also, the smooth surfaces are good. Just like if you consider suppose if you have a table and all, okay, and it's the surface on which you are going to see it. Okay, it's not that much smooth. And another one you have got, okay, you have suppose chair. Okay, so one is not that much, one surface is not that much good. Okay, and another company surface, okay, it has got, it's a very smooth one. Then definitely people will like to sit on the one which is smoother. Okay, which will give you a more better, you can say, ergonomic point of view. Okay, similarly from tribological perspective also we require smooth surface. So tribology is a kind of branch of engineering and technology which actually deals with surfaces mating surfaces, okay, and the wear and tear which are associated with it. Okay, so we know that really it's a kind of study of friction and all, friction and its associated phenomenon, wear, friction, lubrication and all. So all those things actually comes under the tribology. So from tribological perspective also smooth surface is a requirement. That means we know that the smooth surface means coefficient of friction value is generally is low. Okay, and the smooth surfaces, they even if they rub once two surfaces, if they are sufficiently smooth, and even if they rub once again against another, then also suppose the wear and tear etc will be somewhat less and all. Okay, so from tribological perspective also smooth surface is a requirement. Similarly, you can think of another example like the different machine elements which are there, which are whose surfaces are in contact and which have got relative motion in between them. So in those cases, if the surfaces are like properly smooth, okay, they are properly finished, and those components will have a better service life. Similarly, from optical perspective, optical requirement perspective also, the smooth surface is a very requirement. So all those lenses etc in camera lens etc, okay, they are very highly smooth surfaces. Actually their level of surface finish is in terms of nanometer, okay, nanometric level of finish that you obtain. You can think of like suppose, I believe all of you have heard about the Hubble Space Telescope, right? It is actually in the space, it is there, and it is investigating and continuously taking photographs of different, you can say, star, nebulas, all those galaxy. Okay, and some it is taking different photographs and all. Okay, and in those cases you can think of the level of surface finish that is required in the lenses which are used there. Maybe even don't forget about Hubble Space Telescope. Maybe you can even think of all of you are having a smartphone, right? And nowadays the smartphone, they are having suppose a very high level, very good cameras and all. Okay, and in those cameras we have got different lenses, and the surface finish of those lenses, okay, which are used in mobile cameras or other cameras. Okay, it's a very we require a very highly smooth surface. That means the surface finish has to be very good, which in turn states that the surface roughness value that you need to achieve on that surface is very less. Okay, lesser is the surface roughness value, higher is the smoothness, or higher is the finish of this particular surface. Okay, so they are interrelated. So after this much, that means if that kind of surface roughness, or ultimately the smoothness of the surface you need to achieve for doing a certain application, so you have to have a variety of knowledge of definitely different surface finishing operation. A variety of surface finishing operation will also be required depending on what kind of material you want to, what kind of surface, what kind of material, what kind of level of finish that you require. Depending on that, there will be variety of surface finishing operation. You will be discussing those kind of surface finishing operation in this particular module. So you'll see there are different type of surface finishing operation, where some of the operations maybe they will be suitable for small components. Some of the operations it might be useful for bigger components. Some might give you level of surface finish in the nanometric range. Some will like that kind of capability, or some might give you suppose in terms of normal micron and all. And depending on your requirement for that particular type of application, you are going to select a particular suitable process for doing the surface finishing on your product. Understood up to this much why it is required, and what kind of what are the various actually requirement, what was the thing like, yes or no, let me know. Hello, am I audible? Am I audible or not? Okay, thank you. So I believe all of you have understood the requirement of this surface finishing operation. Now there is certain other terms, okay, which are there, which are kind of, you can say, a broader perspective. So we have got certain term like surface engineering. So now what is this surface engineering? So surface engineering, it can be termed as a multidisciplinary activity which is intended to tailor the properties of the surfaces of some manufactured components so that their function and serviceability can be improved. Okay, so that those conditions, okay, those activities actually which actually are performed on the surfaces of a manufactured part, so as to tailor. Tailor means as per your requirement. Okay, that means if you want to have a certain property that has to be developed on this particular surface, and if you're doing certain things, certain job on that particular surface so as to achieve that kind of functional requirement or service requirement, then all those different activities which are performed so as to get that kind of result are, they fall under surface engineering. So surface engineering is a broader perspective. It's not only talks about the like getting the only smoothness of this particular surface, rather it also encompasses all the activities which can give rise to suppose some other functional requirement. Sometimes what may happen, the surface, your intention may be the surface should be harder than that of suppose the rest of the bulk of the material, okay, of that particular product. So that kind of thing may be there. Similarly, sometimes you might require a hydrophobic or hydrophilic surface, okay, depending on your requirement. Okay, so that also will fall under the surface engineering because you are tailoring the property of that particular surface. Sometimes you might have heard about self. Nowadays people are talking about self healing of surfaces. Okay, so nowadays self-healing materials, etc., from materials point of view, okay, that kind of research have come up, and there are certain self-healing alloys, self-healing materials are there. So even the surfaces which are worn out, they can be that this kind of self-healing properties can be given. So those will also fall under surface engineering because somehow or the other, actually, you are tailoring the whatever is the functional or the service requirement, okay, serviceability of that particular whatever is the component you have selected. And with surface engineering, actually we only talk about the improvement of all those kind of properties, okay, functional property or serviceability. We cannot say that suppose a particular proper process you have carried out on that particular surface and it has deteriorated the or degraded the quality of that particular surface, then that will not fall actually under the surface engineering. So surface engineering, its intention is to, it has, you have to improve the functional or serviceability of that particular component. Okay, and in general, the resulting engineered surface, it generally provides some better wear resistance capabilities, similarly corrosion resistance capabilities, or maybe high temperature resistance and all, okay, or some better electrical and optical properties than that of the other bulk material. Okay, and all those actually, whatever is the type of tailoring that you do in terms of maybe wear resistant property, maybe the corrosion resistant property and all, okay, they will improve the service requirement. Okay, generally these are improved as per the service requirement. Okay, so that is what is the intention of surface engineering. And now we know that whenever we're talking about manufacturing some parts, and one of the major player in manufacturing is the different material removal processes, okay, like different machining processes and all. Okay, and in as we already know, so depending on what kind of tool, what kind of method, etc., you are using, machine and tooling, etc., okay, you are going to generate, where that particular process is going to generate a wide variety of different surface textures, and those are generally referred to as the surface finish. Okay, so what kind of texture that you have achieved on this particular resulting surface, that is nothing but the surface finish, achievable surface finish. And the different cutting processes, they leave a wide variety of patterns, surface patterns on that particular material, patterns or marks you can say, and the quality of the finished surface, and then it is discussed in terms of the roughness of this particular surface. So previously, whatever we are talking about, surface roughness, etc. So the quality of the product, finished surface, it will be discussed in terms of its roughness. So if The roughness is more, quality is that means less, roughness value is less, that means quality is high. So ultimately, also we have already discussed roughness and smoothness. They are interconnected, interlinked. So higher is the roughness, lesser is the smoothness. Lesser is the level of roughness, higher is the level of smoothness. And ultimately, the surface finish will be higher if the roughness value is lower. Okay, so and this there are certain ways we get this particular surface roughness value. Okay, that means, see, whenever we're talking right now, if you only have a feeling of this particular surface, this is a smooth surface or this is somewhat rougher and all. So in engineering, only having the qualitative thinking, okay, qualitative thinking will not help always. Okay, we have to have quantitative analysis. So we must know in terms of certain parameter, that means what is the value of it, that some numerical values will be required, and that numerical value actually, which is going to give you the indication about the quality of the surface or the finishing of this particular surface, is nothing but the value of the surface roughness of that particular surface. Okay, higher is the surface roughness value, lesser is the level of finishing, or the lesser is the surface roughness value, higher is the level of finish. That means, if we think, say, suppose a particular surface, after a certain surface finishing operation, you have obtained a value of surface roughness which is 5 micron, suppose. Okay, and another surface which has been produced by some other method, maybe, okay, it is giving a surface roughness value of suppose 8 micron. Okay, so which one do you think is a better surface, whose surface finish is good? 8 micron surface roughness value, or this one, okay, or 5 micron? So generally surface roughness, we consider the RA average, okay, roughness average. So suppose for one it is RA value is suppose 5 micron, and for other surface it is 8 micron. Which one do you think is having a better finish? Which surface? This is suppose surface A, RA value is 5 micron. Surface B, RA value is, surface roughness average value is 8 micron. Which one is a better surface in terms of the quality, surface roughness? Okay, who will tell me? Bhaskar, you tell me.
Sir, কি?
Okay, Sampailar, you tell me.
Sir, what's the question?
Tritiraj, you tell me.
Sir?
Yeah, you give me the answer. Bebeto, you give me the answer. Bebeto is not even here. Dizaras, Karan. See, it shows that most of you have just logged in, and some of you are not even here. Avinash,
Yes, sir. The surface A, sir.
surface A is better or worse?
So, roughness better, sir.
Okay, okay, that's the correct
Sir,
answer.
most
So,
of us are replying on chat box. Can you see, sir?
huh?
We are actually replying on chat box due to noise, sir.
You are replying in the chat box. Yes, sir. Yes, sir. Manas. Okay. Now. Okay, yes, sir. That is. Yeah. Okay, Manas. I have not asked even you. Okay, I have actually called the names and I have asked. Okay, thank you for the answer, Manas. Though. Yeah, your correct answer is also correct, Manas. Bebeto has given B as the answer. So no, Bebeto. So as you have said, okay, RA value for surface A is less. That means it is having a better finish. Okay, that means roughness is less means what? Smoothness is good. Okay, or the surface finish is better. So with this done, we'll stop here for today. And other terms, what are the different terminologies involved with respect to the surfaces that we have already previously shown you, na? Okay, this way, like we can have the pattern of the surface and all. So what are the different like words, like parameters like waviness spacing, what is called the surface roughness or surface profile or like that. Okay, those things we will discuss in the next class. So in this class, we'll stop here for today. So I'll be taking the attendance now, and you can respond to your attendance. Okay. Okay. Respond to your name calls. Porimal,
Yes, sir.
Harsha,
Present, sir.
Sivanus, Sivanus,
Yes, sir.
Angsuman, Angsuman, Meren,
Present, sir.
Avinash,
Present, sir.
Sampiler,
Yes, sir.
Raktim,
Yes, sir.
Rajdeep,
Yes, sir.
Priyanus.
Yes, sir.
Priyanus is here. Okay.
Yes, sir.
Simanta,
Present, sir.
Tijaras,
Yes,
Tijaras.
sir. Yes,
I have
sir.
been calling you during the class. What you're doing?
Sir,
Sukhbir,
answer জানা নাছিলো কাৰণে
Sukhbir.
Yes,
নাজানিলে
sir.
বুজি পোৱা নাই কৈ দিবা. If you have not understood the things, if you have confusion, you can ask. Karan,
Yes.
Dixita,
Present, sir.
Bhaskar,
Yes, sir.
Farhan, Farhan, Tamo,
Present, sir.
Bhargav,
Present, sir.
Triti,
Yes, sir.
Manas,
Yes, sir.
Ricolo, Ricolo, Balam,
Yes, sir.
Milo, Milo, Bebeto, Bebeto.
Yes, sir.
Okay, so 1, 2, 3, 4. Okay, 4% action. Okay, thank you everyone for joining. Anyone left out? No, right? Okay. Okay, thank you everyone for joining this class. If you have any question, you can ask, or otherwise we'll stop here. Okay, thank you.
Thank you, sir.
Okay, okay. Okay,
sir.
we'll meet in the next class. Okay, thank you everyone.